Welcome to our brief introduction on biomechanics. We should probably start with what is biomechanics. If I look up just a definition on Google, it says the study of mechanical laws relating to the movement or structure of living organisms. That's quite broad. So just as an introduction, in terms of applications, biomechanics is the reason that we are concerned about body position when performing exercise. It helps us select the proper lever arm or distance that weights should be from the body in order to achieve our results safely. And it helps us analyze the external loads and forces that come into play when we move the body through space. Here are a few examples. So at first, you might look at this overhead squat and go, yeah, that's great, that's fine, that's wonderful, let's add some load. And you'll notice that this person only has a dowel rod above their head. You'll also notice that the shins are almost perpendicular to the ground and the torso is coming quite far forward. Well, the laws of biomechanics force gravity to align this bar straight up and down. That's normal. However, we see quite a bit of limited ankle mobility here that we'd probably want to address prior to adding loaded bars. Otherwise, more of the force is going to go through the back and create a potentially dangerous situation for this client. Next, let's look at lever arms. So if we're performing a delt raise or a side T raise, why is it important that we lighten the load? Why can't I perform this exercise with the same weight that I do an Arnold press or a military press or an L raise? And the reason has to do with a lever arm. The distance of the weight from the center of the body is greater than in all those other lifts. Therefore, the weight I select, or the load I select, or the intensity is another name for load and weightlifting, must be quite a bit lighter than in all those other lifts. If I attempt it to perform this lift with the heavy weight I use in the other lifts, I would create an upward shear that's unstabilized by the muscles in the shoulder and potentially create damage to the shoulder. Let's look at some types of external forces. So when I go to the gym, I go, oh, I could use a dumbbell to do this, I could use a band to do this, I could use a machine to do this. It's important to understand what type of force we are placing upon the body. So for example, a dynamic constant force, meaning relatively constant external load, would be a free weight or a pulley-based cable. A dynamic variable force would be a band, a spring, or a cam-based machine. A cam is a slightly oval-looking pulley, so the resistance changes throughout the range of motion, and it's designed, if you set up your machine correctly, to match the strength curve of the muscle. So for some of you, you might be going, oh yes, I got this, great, good information. And for some of you, this might be for your first exposure to any of these concepts. No worries. We're going to look at more of the internal forces and mechanics of the body in HS 150, which is our kinesiology course, and then we'll get into a deep dive of these biomechanical, mostly external forces and how they interact with the internal forces in the body in HS 202, which is our biomechanics course. Thank you for taking time to consider some introductory biomechanical concepts.